Welcome to Lesson 3 of our Radicals unit. Today's lesson is in two parts to keep the video size down. In part 1, we're going to look at using prime factorization as a way to simplify square and cube roots. In part 2, we're going to look at using perfect squares to simplify square roots. Some of you may know the term prime factorization as doing the factor tree. Remember that factors of a number are the numbers that will multiply together to give me this number. So if we take the number 1 and 36 are factors of 36 because 1 times 36 is 36. So 2 times 18, so 2 and 18 are factors because they multiply together to give me 36. 3 times 12, 4 times 9, and 6 times 6. These are all factors of 36. Prime factorization is breaking a number down into only its prime factors. Remember that prime numbers are numbers whose only factors are 1 in that number, so nothing else can multiply to give me a prime number. So let's just start with any of the factors of 36 that we just listed. Let's do 2 and 18. So I start the branches of my tree. So 36 is 2 times 18. Then I look at my numbers and I see 2 is a prime number. Nothing will multiply to give me 2 besides 2 and 1. So since that number is prime, I just bring it down one more level. 18, however, I do have factors of 18, so let's try 2 times 9. Okay, so again, 2 is prime, I just bring it down. This 2 is prime, I bring it down. And 9 has factors of 3 times 3. 3 is a prime number, 2 is a prime number. So here I am left with only prime factors. So the prime factorization of 36 is 2 times 2 times 3 times 3. So this is the prime factored form of 36. Let's put our multiplication. 2 times 2 times 3 times 3. So we're going to bring this back to help us simplify radicals, and this method is useful for simplifying any radical. It's not just square root radicals. We're going to use this method for both square roots and cube root radicals. What exactly does it mean to simplify a radical? And basically, what it means is I want to get the number that's under the radical, I want to get the radicand into the smallest number possible by taking out any factors of that number that repeat. So if there are two 2's in there, I want to bring them out. So we're trying to eliminate any repeating factors of the radicand. So let's see what that looks like. So here we've got 64. So we want to try to bring out any duplicate factors. So let's go ahead and start by what are my factors of 64? So let's start with 4 times 16. I know that 4 times 16 is 64. The difference here is I don't want to lose my radical symbol. When we were just doing the factor tree, we just did our branches and carried on. Here we want to make sure we keep our radical symbol through each step. 4 is not prime, it breaks apart into 2 times 2. Okay, 16, let's do 2 times 8. Okay, so keep my radical symbol. My 2's are all prime, so I can just go ahead and bring them down. And 8 will break apart into 2 times 4. Alright, don't want to lose your radical symbol or your multiplication signs. So, again, bring down your 2's. And 4 breaks apart into 2 2's. So now, all of my numbers under the radical are prime numbers. They're all 2. So this is where I want to look at the index. So I want to look at the index. And if you remember, the index is this number that would be in this little crook here. So this is our index. Notice there's not a number explicitly written here, but remember this is a square root radical, so the number implied there is 2. The index is going to tell me how many numbers I'm going to group together in order to bring one outside. So here, I need to group numbers in pairs or in groups of 2. So the index tells me how many to group together. In this case, I'm looking for groups of 2. So here's a group of 2, here's a group of 2, and here's a group of 2. Now when this happens, when I have a group of however many the index tells me, that means I can just kind of mark them out and bring one number to the outside. So I bring one of these 2's to the outside. Here I'm going to mark through my group and bring another 2 to the outside. I'm still going to multiply these numbers together. So again, mark it out, bring it to the outside, and multiply. My last step is to look and go ahead and multiply the numbers on the outside. So 2 times 2 is 4, times 2 is 8. So I end up with 8 here. And then I look to see what's left under my radical. I canceled out all the groups of 2 under my radical, so I don't have anything left. So the radical goes away and I'm left with just 8 on the outside. So the square root of 64 simplified is 8. And we could have answered that from the very beginning. We know that the square root of 64 is 8 because 64 is a perfect square. But this is the way it works if we had gone through the method of prime factorization. Let's look at another one, and one that isn't going to work out perfectly. 64 was a perfect square, so I ended up with nothing left under the radical. 32, however, is not a perfect square, so let's see what happens. So let's go ahead and do our factors of 32, and I'm going to start using 4 and 8, because I know that 4 times 8 gives me 32. Neither of these numbers is prime, so I need to go ahead and break them apart. 4 turns into 2 times 2, and 8 turns into 2 times 4. Don't want to lose my radical symbol. So 2 is prime, 2 is prime, 2 is prime. 4 breaks apart into 2 times 2. So now all of my numbers under the radical are prime numbers, so I need to look at the index. Here this is a square root, so my index is 2. So that means I'm looking to put my numbers into groups of 2. So here's a group of 2, and here's a group of 2. I don't have anything else to pair this one with, so I just leave it alone for now. So when I have my groups, I can mark them out and drag them to the outside, drag one to the outside. So on the outside here, I am left with 2 times 2. And what's left under the radical, I'm left with the radical and a 2. So when I put those together, I go ahead and multiply the outside numbers. 2 times 2 gives me 4 on the outside. And then I bring down my square root symbol of 2. So simplified, the square root of 32 becomes 4 times the square root of 2. Let's check that on our calculator and see if that turns out the same way. So here we have 32. The square root of 32 is 5.65685. Okay? So let's see if we clear that and do 4 times, so 4 times the square root of 2. And we end up with the same number, 5.65685. Simplifying cube roots, we do the same thing. We're going to go to the prime factorization, except the index now is going to be 3. So instead of grouping things in groups of 2, I need to have a group of 3 in order to bring one number to the outside. So let's see what that looks like. Here I've got, you can tell this is a cube root because I have an index here of 3. So the cube root of 125. Well, my first step is I need to go ahead and do the prime factorization. I know that 25 times 5 will give me 125. So I keep my radical with my index. 5 is a prime number, 25 is not. So let's go ahead and break 25 down into 5 times 5 and then bring down my 5. So now all the numbers under the radical are prime. 5 is a prime number. And now I'm looking, I need to have a group of 3. Luckily, I have these 3 5s that I can group together. So I have grouped 3 5s together, so I can mark through my group and bring a 5 to the outside. There was nothing left under the radical, so the radical goes away and I'm left with just 5. So the cube root of 125 is 5. So it ended up being a perfect cube. For 24, let's see, our factors of 24, let's try 4 and 6. 4 times 6 will give me 24. So let's go ahead and bring down our radical. But these numbers are not prime, so we need to go ahead and break them apart. 4 is 2 times 2, and 6 is 2 times 3. Bring down my radical. So now my index tells me I need to have a group of 3 in order to bring something to the outside. So here's a group of 3. I've got 3 2's together. So I can mark through them and bring one to the outside. So now I have a 2 on the outside and I have a 3 left under the radical. So to simplify that, I take my 2 and I bring down my radical with my index of 3. So I end up with 2 times the cube root of 3. I cannot multiply this number and the index together. I just simply leave it as 2 times the cube root of 3. This is the end of part 1 of our 2-part lesson on simplifying radicals.